All right, get ready for this one. We're about to go on a journey that starts with a totally free, simple tool for 3D artists and ends with the actual physical alloys for a hypersonic engine. Sounds kind of crazy, right? But stick with me because it all connects. So it all starts right here with a free add-on for Blender, the 3D software a lot of you probably use. I mean, you could literally go find this thing on Gumroad or the Blender extension site right now. It's called ArcEdge. And at first glance, it just looks like some little utility for making and measuring curves, the kind of thing you might download, mess with for 5 minutes, and then completely forget about. But this little tool, it's the key. It's the first step down a rabbit hole that goes way, way deeper than you could ever imagine. So here's how we're going to break this all down. First, we'll look at the tool itself. Then we'll get into the wild science behind what it's actually measuring. After that, we'll zoom out and look at the whole ecosystem behind this thing, see it in action in a kind of digital lab. And finally, the payoff. We'll see how it all leads from lines of code to actual physical metal. Okay, first up, Section 1, a curious tool. Let's dig in. Okay, so on the surface, its features seem pretty straightforward. It helps you create and measure something called finite arcs. We'll get to what those are in a sec. And it says its job is to create data to feed everything else. Kind of vague, right? But then you spot it, right there at the bottom, a little note. This thing is just a side product of a main project at a company called Radical Deep Scale. Now that's where things get really interesting. And then, bam, the creator leaves this little bomb in the description, a warning almost. They say, and I'm quoting here, "You have to remember this is a measurement tool. It's not for making pretty art. It's not for running a simulation. Its job is to measure things, specifically fluid dynamics." So the question becomes, what on earth are they trying to measure? And that brings us right into Section 2, a ruler for chaos. Yeah, we're leaving the 3D art world behind and jumping straight into physics. So, this term finite arc, what is it? Well, think about a perfect circle. It's easy, right? It's predictable. You know exactly what it's going to do. A finite arc is, well, it's everything else. It's the messy, chaotic, beautiful curve you see in the water behind a moving boat. It's the turbulence from a jet engine. It's chaos given a shape. And this really gets to the heart of the problem. Symmetrical stuff like circles, easy. We've had math for that for centuries. But the chaotic stuff, the finite systems, that's a whole different beast. It's like, how do you measure the shape of smoke with a wooden ruler? You can't. It's the wrong tool for the job. And that is the fundamental problem this little Blender add-on is trying to solve. It's designed to be a ruler for chaos. Okay, so now that we know what it measures, let's look at who is doing the measuring. This is Section 3, the Dart Meadow ecosystem. Because, this little tool, it's not a one-off project. Not even close. It's just the tip of a massive iceberg. And suddenly, the picture gets a whole lot bigger. We're not just talking about one company. We've got Dart Meadow LLC, we have Radical Deep Scale, Dart Skyboard, and these project names keep popping up, like Ariel NPU and ArcLake. You start to realize, okay, this isn't just some developer's side hustle. This is a serious, organized, and deeply interconnected operation. And if you had any doubt, you just have to look at their own public documents. Their GitHub page spells it out in black and white: aerospace, tooling, and engineering. So yeah, that free, simple Blender tool, it's the friendly front door for what is, for all intents and purposes, a private aerospace research and development group. All right, so we know who they are. Now let's see what they're actually doing. Welcome to Section 4, a digital laboratory. Okay, check this out. This is ArcLake. It's basically a digital chemistry lab for simulating molecules. And what do you see? Right there in the physics controls, ArcEdge factor. It's right there. The exact same concept from that little free add-on is being used as a core control knob for simulating physics down at the molecular level. It's the same DNA. And it doesn't stop with chemistry. This here is Ariel. It's a tool for designing AI hardware. The chips that power neural networks. And wouldn't you know it, there it is again. An ArcEdge 3D graph is the main way they visualize and feed complex data into this thing. So they're using this same core idea to understand both molecules and artificial intelligence. It's absolutely wild. And, just to prove this isn't some fancy mock-up, if you peek under the hood at the actual code, it's all there. The variables for the graph, the math solvers, the whole shebang. It's a real, working, incredibly complex software suite. This is the real deal.
Which brings us to our final section, and honestly, the part that ties it all together in the most mind-blowing way. Section 5, from code to alloy. This is what it's all been building towards.
So, why? Why build all this incredible software? Why go to the trouble of measuring chaos? The answer is to make these real-world physical things. 2 unique, high-performance metal alloys. All that digital simulation, all that code, it's being used to design and engineer actual matter. I mean, take a look at the Hercules alloy. They literally give us the recipe. It's 60% aluminum, 30% titanium, and then these little pinches of copper, tungsten, zinc, and cobalt. This isn't a theory. It's a precise, engineered formula for a brand new material. And you might wonder, why that specific mix? Well, a technical doc for their other alloys spills the beans. It's all about the tungsten. The whole point of this elaborate digital process is to supercharge the properties of tungsten for one specific purpose: hypersonic engineering. We are talking about building parts for things that fly at Mach 5 and beyond. So let's just step back and look at the path we just walked. It is incredible. You start with a free tool for 3D artists, a tool designed to measure chaos. That tool feeds data into these insanely complex digital labs for chemistry and AI. Those labs then simulate and design brand new materials from the ground up. And the final result, the end of the line, is a physical alloy built for a hypersonic engine. It's just, wow. The whole thing is just, it's a staggering journey that began with a free add-on on a website. And it really makes you wonder, doesn't it, if a journey from a single line of code to the alloys of a hypersonic engine can hide in plain sight? What other world-changing innovations are out there just waiting to be discovered?